Actually, there have been two changes in this one. We will put such an address segment. For RAND department. I'll mark it for you. Okay. This is the subnetting we do. Equivalent to divided 2 subnets. Next we're going to start assigning. I plan to assign to the RAND department. Above this 194.2.3.0. N is a 25-bit mask. Let's calculate the network address of this network segment. 194.2.3.0. This is its web address. 25-bit mask. Its broadcast address. That is, all the following bits are set to 1. 255 minus 128 is 127. Change this 0 to 127. Okay. That is to say, we now put such a network segment assigned to RAND department. So, we can fill this network segment to the RAND department. Then let's look down. When I now divide this network segment to it. In fact, this network segment is given to it. So what is the address that can be allocated at this time? I just created 2 subnets. Then I used one of them for the RAND department. Then now, what are the addresses that can be assigned to other departments? Okay. There's only one address left. Because of the 0.025-bit mask, already used by others, can now be assigned to other departments. That's all that's left. In the future, when we calculate, if you do subnetting again, you can only move back from its foundation. Okay. The first part is actually the same. You can follow my logic after class. Then do the math yourself. First to the project department. To the marketing department. To the finance department. You look at the process between them. At last, we can definitely figure it out. That is to say, what we're talking about as a whole. Variable length subnet mask. Let me stress again. According to us, ABC classes are called classed. Such a mask has the form 8 bits respectively. 16-bit, 24-bit mask. If according to such a mask, Class C must have only 8 host bits, then the default is 254 addresses per network segment. You will find these departments add up to 254 addresses are enough. 200 people in total. That explains. If there is a Class C address, 200 people are enough. But now if you don't do subnetting, that's not enough. Because I want them to be on different network segments. But if you don't subnet, that by default, these 254 addresses must be in one network segment. So now there is only one network segment. 254 addresses. 24-bit mask. There is really only one large network segment. It's called the 194.2.3.0 network segment. That is to say, the first 3 are fixed. This is the network bit. 254 addresses in one network segment. For RAND department use only. Or only available to the marketing department. Other segments have no address. You want the address to be enough. Also wish they were in one segment. No subnetting yet. This is impossible. That's what we mean by subnetting. Now also in a large address segment. But due to subnetting, we can do it both to accommodate all people. It can also be done that they are in different address segments. That's the point of subnetting. We subnet. Not just for calculations. You need to know this scene. Okay. Finally, let's briefly talk about classless interdomain routing. There will be a new format here. Classless interdomain routing. VLSM we talk about. It is the network borrowing from the host bit. We can put a network segment into multiple different subnets. For a large community, make some logical divisions. Each subnet corresponds to an address range. Eventually these addresses will be applied to the network. Means this. Now, everyone can see. It summarizes the network segments on the right. Did you discover it? Classless interdomain routing and VLAM is an opposite technique. The network segment itself is a 24-bit mask. It is changed or notified. Finally made a summary. Aggregated into 22 bits. Classless interdomain routing is called CIDR. It has an alias called SuperNet. What exactly does it mean? I'll draw a picture to explain. We now do a subnetting. Look, here is a device. In this device, I now segment the network. 2 different subnets. For example, it's 2 divisions of a company. Left is 192.168.1.0 25-bit mask. Right is 192.168.1.128 25-bit mask. Actually, it was originally the biggest word. Should be 192.168.1.0 24-bit mask. I have now subnet. I'll test everyone first. If a data comes now, this data is 192.168.1.100. Then please, is this data sent to the left or to the right? This is a very basic question. Okay. Hair to the left. It's covered by this address on the left. When data is forwarded, it must be according to different subnets to forwarding address, because it belongs to the left. So it must be a left turn. But you will find, for this picture, now it's just a borrowed one. Borrow a bit to divide 2 subnets. Borrow another. Divide 2 subnets. If you borrow 6, that is, the mask becomes 30 digits. Actually, I divided 2 to the 6th power of subnets. 64 subnets. We are exaggerating. I divided 64 subnets. It is equivalent to the original network segment. Can be divided into many network segments. Each network segment contains a different address range. If there is a data in the future, also into this device. Data forwarding. But we have divided so many network segments here. Of course, the interface of the device is not enough. So I'm just an exaggerated rhetoric. We have divided so many network segments. If there are too many network segments, I want to forward data. More information to unlock. More entries on the device. To match the data. Because there are too many network segments. Different network segments are different routing entries. To match. Then you will find more matches. This is equivalent to. Originally, I was going into a neighborhood to find someone. This area is divided into 2 parts. I can find someone directly from this area. Either go left. Either go right. Divided into A-B buildings. Later, the district was divided into 64 districts. Then I'm looking for someone. I also need to confirm